Hello students, welcome to my class. In my last lecture, I was discussing about the theories related to this chapter, chapter number 5, that is surface chemistry. Today I am going to discuss few questions related to this chapter and completely board pattern, and definitely my friend it will help you a lot. So let's start the topic here. That is, why is adsorption always exothermic? I am moving. Look at. As we know, what is the reason of adsorption? First of all, tell me. Reason of adsorption. Yes, sir. Reason of adsorption is, suppose there is a surface clear. Now, if there is a surface and due to the unbalanced force, here is the unbalanced force, my friend. This is the case. Do you remember during my lecture I have also discussed these things. This is the unbalanced force. Due to the unbalanced force, what will happen in this case? That is, the particles accumulate at the surface. When the particle accumulate at the surface, that is, there is a decrease in surface energy. Definitely there is a, when particle accumulate, then there is a decrease in the unbalanced residual force, which ultimately decrease the surface energy. And if there is a decrease in surface energy which appears in terms of heat, and in this case what we find, delta H is negative. If delta H is negative, the process is exothermic. What I am telling, why adsorption is always exothermic? Adsorption is always exothermic because during the adsorption, particles accumulate at the surface of liquid or at the surface of solid. Due to this reason, there is a decrement in the residual unbalanced force, which ultimately decrease the surface energy, and it will appear in the form of heat. So we will say that is adsorption is always exothermic. Clear to you? Now I am going to rub this part and we will discuss the next question. Wait for a moment. Next one is, what is the role of desorption in the process of catalysis? What is the role of desorption? First of all, we know what is catalysis. Catalysis is the process that is in which the rate of a reaction increased by introducing a substance which enhance the rate of reaction without consuming into the reaction. For example, if I write here N2 plus 3H2, definitely it gives you, my friend, 2NH3. Clear to you? In this case, what do we observe here? We observe here iron as a catalyst and molybdenum as a promoter. Iron as a catalyst and molybdenum as a promoter. Am I right? Yes, sir, you are absolutely right. And what will happen? What is the role of desorption in, what is desorption? Desorption means, listen carefully, my friend, desorption is opposite of absorption. Yes, sir, opposite of adsorption. That is, the particle leaving out the surface of the adsorbent. Clear? What will happen when desorption take place? That is, the particle will release from the catalytic surface and we get a fresh surface of a catalyst for further reaction, my friend. Again I am repeating, what will happen in this case? That is, during what is the desorption? Desorption is opposite to adsorption. That is, desorption will create a fresh surface of catalyst and which will proceed the reaction further. That is the role of desorption in the process of catalysis. Clear, my friend? Yes. Now I am going to rub and we will discuss the next question. Listen carefully what I am telling. Now let us move to the question number 3. Look at this is 2 marks question. Now listen carefully. Explain what is observed. It's very simple. When a beam of light is passed through an colloidal solution. When a beam of light is passed through a colloidal solution, then what will happen? The scattering of light take place. Yes, sir. Scattering of light. Clear? The scattering of light take place, and this scattering of light is known as, my friend, Tyndall effect. The scattering of light is known as Tyndall effect. Clear to you? Again I am repeating, when a beam of light is passed through a colloidal solution, that is scattering of light take place, and this scattering of light is known as, my friend, Tyndall effect. Clear to you? Now second, an electrolyte NaCl is added to ferric hydroxide solution. Ferric hydroxide solution is, we know, positive colloidal sol. Definitely. Now when we add NaCl, that is the negative part, that is NaCl electrolyte will act as an electrolyte, then the negative part, that is the Cl minus ion, will coagulate the positive colloidal solution, coagulate the ferric hydroxide solution. That is what will happen in this case. Coagulation take place. Coagulation take place. And what is coagulation? Do you remember? Yes, the process of precipitation of the colloidal sol by using the electrolyte, by using the suitable electrolyte, is known as, my friend, coagulation. Now electric current is passed through a colloidal sol. What will happen when electric current is passed through a colloidal sol? The particle will move, the colloidal sol particles will start moving. Again I am repeating, the colloidal sol particle start moving in the influence of electric field. If it is a positive colloidal, then it will move towards negative electron. If it is a negative colloidal, it will move towards the positive electron. Again, positive colloidal, that is move towards negative electron, negative colloidal move towards positive electron. By this method, by applying the electric field, we find it out which type of colloidal it is. Either it is positive colloid, either it is positive colloids, or either it is, my friend, negative colloid. Positive or negative colloids. Clear to you? Now one more thing, during my lecture I have discussed, only the dispersed phase particle will move. Only the dispersed phase particle moves, that is they carry charges. They carry charges, not the dispersion medium. Dispersion medium are always neutral in nature. So these are the things related to these 3 questions. Clear, my friend? Yes, sir, definitely you are correct. Now I am going to rub and we will discuss the next question. Now wait for a moment. Let us move to the next question. Now, what is demulsification? What is demulsification? As we know, if I talk about emulsion, Yes, emulsion is a liquid-liquid interface. It is the colloidal soul of liquid and liquid. Clear to you? For example, if I talk about milk, if I talk about butter, cheese, these are example of liquid emulsion. Now demulsification, as we know, there is a different type of liquid particles and they form colloidal soul. Yes, colloidal soul of liquid and liquid is known as emulsion. Now the process of removing the liquid components, is known as, my friend, demulsification. And name to demulsify. Demulsification is done either by boiling, or the second one is, my friend, or centrifugation. By centrifugation. And what are few example of demulsifying agent? That is soap solution, soap sol. Clear to you? Then sulfonic detergent. Lyophilic sol. For example, starch, cellulose, these are the example which act as a emulsifying agent. What I am telling will act as a emulsifying agent. So what is demulsifier? What we am telling, the process of removing the liquid particles is known as opposite of emulsification. Emulsification, that is the process in which we form the colloidal soul of two liquid like milk and butter. Opposite, to separate them, is known as demulsification. Demulsification is done either by boiling or by centrifugation. This question carry 2 marks. So we have to answer this question around 20 to 40 words. Clear to you? Now I am going to rub this part and we will discuss the next question. Wait for a moment. Now the solution is, action of soap is due to emulsification. What is emulsification? That is the process of formation of emulsion or colloidal soul of liquid. Clear? As we know, soap is, my friend, sodium or potassium salt of fatty acid. CH3, C17H35, COO minus Na plus, COO minus Na plus, that is sodium stearate and sodium permanganate. As we know, it has long hydrocarbon chain. Yes, when we prepare the soap solution, listen carefully, when we prepare the soap solution, now suppose this is a soap solution, okay, this is a soap solution. Now if I drop a oil, then in soap solution, then what will happen? The long hydrocarbon chain comes at the surface of the oil, like this, comes at the surface of the oil, and ultimately decreases and will ultimately decrease the interfacial tension between oil and soap water. If there is a decrement in the interfacial tension between oil and soap solution, then what will happen? There is a formation of colloidal take place. Clear? So here soap act as a emulsifying agent, and it decreases the interface. If there is a decrement in the interfacial tension take place, then it will act as a emulsifying agent, and there is a emulsification take place, and there is a aggregation, or you can say the association of the molecule, and this association, that is, this is also example of associated colloid, and this comes into existence via micelle formation. This is micelle, that is the cleansing action of soap. Clear to you? Again I am repeating, as we know, soap is a sodium salt or sodium or potassium salt of fatty acid. It has a long hydrocarbon chain which is hydrophobic, that is water repelling, hydrophobic, and COO minus, that is hydrophilic. Clear to you? Now when we in a soap solution, when we drop when we take a drop of oil, when you pour a drop of oil, what will happen, that is the hydrophobic part comes accumulate at the surface of the oil, and it decreases the interfacial tension between oil and soap. Now there is a formation of emulsion take place between oil, and that is colloidal take place between oil and soap. So it will act as a emulsifying agent, and this happens via micelle formation, that is the associated colloid. Clear to you? This is the case that this carries 3 marks, so you have to draw the figure also, my friend. Am I right? Yes sir, you are absolutely right. Now I am going to rub this part and we will discuss the next question. Wait for a moment. Now the next one is question number 6. What is shape selective catalysis? I have discussed this thing in my lecture also. I have discussed all the things in my lecture also. Still, what is shape selective catalysis? The catalysis which depends upon the pore structure of catalyst and the structure, or you can say the size of the reactant, or you can say the product, that is known as shape selective catalysis. Zeolite due to its honeycomb structure, that is pore structure, act as a good catalyst, and the shape of the zeolite would help the catalytic action, which enhance the rate of reaction, and this process is known as shape selective catalysis, my friend. It has structure, my friend, honeycomb structure. Clear to you? Now, what are enzymes? This is again a simple question. Enzymes are biochemical catalysts. Enzymes are nitrogenous compound which we get from the living beings and act as a biocatalyst. That is enhance the rate of biochemical reaction. What is the mechanism of enzyme catalyst? We know, key and lock mechanism. Do you remember? Follow my previous lectures as well as the ebook. You will get the complete mechanism. What are enzymes? Again I am repeating, enzymes are nitrogenous compound which we get from living beings and act as a catalyst for biochemical reaction. For examples are invertase, diamase, urease, maltose, etc. All are the example of enzymes, maltase, etc. Clear to you? Now you can easily solve such kind of question. This chapter is completely theory based, my friend. Now the next one is question number 7. Now it's your turn. How will you explain this? Look at the thing. Explain the terms here: electrophoresis, coagulation, dialysis, and Tyndall effect. Now help me out. What is electrophoresis or cataphoresis? Tell me, my friend, what is electrophoresis or cataphoresis? What is coagulation? What is dialysis? And what is Tyndall effect? Now tell me. Electrophoresis or cataphoresis, the movement of the colloidal particle under the influence of electric field is known as electrophoresis or cataphoresis. It decides whether the colloidal is positive, positive soul or negative soul. Now what is coagulation? The conversion of colloidal soul into precipitate by using a suitable electrolyte is known as coagulation. Clear to you? If you want to coagulate the positive soul, you require negative electrolyte, that is the electrolyte containing negative ion. Electrolyte generally contain positive and negative ion, but the power of negative ion will be more dominant here. And how to find the coagulating power? That is Hardy-Schell's law. I have discussed this thing. This point is very much VVI. What is dialysis, my friend? Dialysis, you are very much familiar. Blood dialysis, the process of removal of colloids from crystalloids by using parchment paper or any membrane is known as, my friend, dialysis. Again I am repeating, the process of separation of colloids from crystalloids is known as, my friend, dialysis by using membrane like parchment paper or any other permeable membrane is known as dialysis. Now what do you mean by Tyndall effect? Dialysis are two types, normal dialysis and electrodialysis. If dialysis is done under the influence of electric field, it is known as electrodialysis. Now what do you mean by Tyndall effect? The scattering of light when it is scattering of light by the colloidal particle when it is passed through a colloidal soul is known as, my friend, Tyndall effect. Am I right? Again I am repeating, the scattering of light when it passed through the colloidal soul by the colloidal particles. Clear to you? Now let us move to the next segment of the question. What is the next segment of the question? Question number 8. Now give 4 uses of emulsion. It's very simple. Milk, which we use, is an example of emulsion. Butter, which we use, is an emulsion of application of emulsion. Now in metallurgical process, froth flotation process, we form the emulsion of oil water surface, oil water emulsion, and we use a emulsifying agent, sodium ethyl xanthate, the pine oil, eucalyptus oil. These all act as a collector. Clear? Many many medicines in oil form act as a emulsion. These are the few uses of emulsions, my friend. Clear to you? Now let's move to the next question. What is the next question here? Check it out. Now what are the micelles? Micelles are the associated colloid like this, associated form. And what is the clean? Suppose this is a dirt particle and there is COO minus, 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 COO minus. That is aggregation, or you can say the association of colloid take place. Clear to you? This is the micelle formation, my friend. Now give an example of micellar system, that is, we know that is the cleansing action of soap, that is the complete micellar system. Clear, my friend? This is the thing. And one important thing, this is again a VVI question, my friend, one of the most VVI question. And this question is asked generally, previous year question, they ask you cleansing action of soap. cleansing action of. So I have discussed these things in detail in my lecture, my friend. So follow my lecture, follow the book. This is a VVI question for 2019 CBSE board examination. Clear to you? So write down the micelle formation, completely associated colloid, what is CMC, critical micelle concentration, what is Kraft temperature, memorize all the thing, and definitely my friend it will help you a lot. Clear? Now I am going to rub this part and will discuss the next question. The next question is, listen carefully what is given here. That is the question number 10. First of all, we will do the second part. Give 4 examples of heterogeneous. What is heterogeneous catalysis? The type of catalysis, again I am repeating, the type of catalysis in which the reactant and the catalyst are of different phase. Suppose if I write here nitrogen plus hydrogen, clear to you, in presence of iron, molybdenum as a promoter, it gives you 2NH3. This is the example of homogeneous catalysis. If I write here vegetable C2H4, this is in a gaseous state, plus hydrogenation of unsaturated hydrocarbon in presence of nickel, in presence of platinum catalyst, it gives you that is saturated hydrocarbon. This is also an example of heterogeneous catalysis, my friend. These are the examples, many more examples. That is, if I write here SO2, clear to you, plus half O2, SO2 plus half O2, it gives you, my friend, SO3. This is the basis of contact process in which what we use V2O5. Remember this, the V2O5. So now V2O5 C2H4. Now again if I write here C2H2 C2H2 in acetylene, hydrogenation in presence of nickel, platinum, palladium, what we get here C2H4, and C2H4 further hydrogenation in case of nickel, platinum, palladium, finally divided nickel, it gives you C2H6. These are the example of heterogeneous catalysis, my friend. Lots of examples are also there. Is it visible, my friend? Yeah. Now this is a question. It's very simple. It is completely theoretical, analytical based. You have to analyze, reasoning type you can say. Now read the question carefully, what is given here. Now what is given here, listen carefully. Comment on the statement that colloid is not a substance. Colloid is not a substance but state of substance. What does it mean? Colloid formation depends upon the situation and the size of the particle, my friend. Again I am repeating, colloid formation depends upon the size of the particle and the situation. It is not a state of a substance. It is not a substance. It is a state of a substance. For example, if I write NaCl, NaCl when dissolved in water, it forms solution, my friend. It forms true solution. But when NaCl dissolved in benzene, my friend, it forms you colloidal. Clear to you? What does it mean? According to the number of particles, according to the shape of according to the size of the particle, it decide whether it forms colloidal or not. Again I am repeating, colloidal is not a substance because colloidal formation depends upon the situation and the size of the particle. If the particle size of the particle lies between the colloidal particle range, then it forms a colloidal. That is, it is not a substance but a state of substance. In which state it is, my friend? Clear to you? This is, if in case of associated colloid, you remember, if the concentration is low, then it will not act as a colloid, but if the concentration is high, then it form associated colloid, my friend. That is a micelle formation take place, and particular concentration is known as critical micelle concentration. So this is one of the best question, completely explanatory. Follow my ebook, and in exam I have discussed, I have given you information. In exam you have to write systematically. Clear to you? Why it is? By giving example, why it is not a substance, it is a state of substance. Clear, my friend? So these are the few questions related to this chapter, completely theory based question. If you have a command over the theory, then definitely you can easily experience such kind of question. The weightage of this chapter is around 3 to 4 marks, and they will ask you not numerical, they will ask what is colloidal, what is, give the example of emulsion, 2 marks question, or maybe 1 marks, or maybe 3 marks questions. Clear to you? Why absorption is exothermic, what is the mechanism, reason of adsorption, what is safe selective catalysis, what is the modern adsorption theory. These are the few questions. If you have a command over this question, then definitely you can go through this chapter easily. So my friend, time has come, time to say bye bye. Thank you so much.